Imagine you could step through a door and instantly find yourself on the other side of the universe. Intriguing, isn't it? What you might think as a plot of a science fiction novel might not be so fictional after all. Welcome to the captivating realm of wormholes, a concept that stimulates visions of light speed, intergalactic voyages, and shortcuts tearing through the very fabric of space-time continuum. Understanding wormholes requires diving into the depths of theoretical physics. Essentially, it's a hypothetical bridge or tunnel in space-time connecting two distant points. Not just any 2 points, but ones that may be galaxies apart, alluding to the possibility of cosmic shortcuts. The concept is that you could step into one end of this tunnel and in a blink find yourself in another corner of the universe, maybe light years away. This concept isn't a figment conjured up by science fiction authors and movie makers alone. Some of the brightest intellects in the field of physics have invested ample thought into understanding this concept to demystify its complexities. Wormholes, are they a path to the future, a reality waiting to be unlocked? Or are they simply a product of our ambitious imaginations pushing the boundaries of what's possible? Let's delve deeper to find out. Before we can answer if wormholes are real, we first need to understand what they are. Picture this. You're trying to get from one side of a piece of paper to the other. The most straightforward path is to travel across the surface, right? But what if you could fold the paper so that the two sides touch and then just step through? This is a simplified way of understanding wormholes. Wormholes in the realm of theoretical physics are speculated passages through space-time that could create shortcuts for long journeys across the universe. They are like tunnels with two ends, each at separate points in space-time. Think of them like cosmic shortcuts, a passage through the fabric of reality itself. Now let's dive a little deeper. The concept of wormholes comes from Albert Einstein's theory of general relativity. Simply put, general relativity is the modern understanding of gravity, which describes how massive objects like stars and galaxies can curve space and time around them. It's as if the universe is a giant rubber sheet, and heavy objects create dips in this sheet. This bending of space-time can potentially create a tunnel-like shortcut, a wormhole. But it's not that simple. Wormholes are incredibly unstable. Without something known as exotic matter to hold them open, they would collapse in a fraction of a second. This exotic matter is yet another theoretical concept, hypothesized to have negative energy density and a large negative pressure. In simpler terms, it's the stuff that would prevent a wormhole from becoming a cosmic dead end. Of course, all of this is purely theoretical. These concepts are based on mathematical models and calculations, and while they make sense on paper, or rather on the rubber sheet of space-time, we have yet to observe or create a wormhole in reality. So, in theory, wormholes could be shortcuts through space-time, but is there any evidence that they exist? Stay tuned as we delve deeper into the reality of wormholes and the mysteries they hold. The truth is, as of now, wormholes remain purely theoretical. This statement may sound like a science fiction spoiler, but it is a fact grounded in our current understanding of the universe. Wormholes, these fascinating shortcuts through the fabric of space-time, are solutions to Einstein's field equations. Yes, they are part of the mathematical framework of general relativity, Albert Einstein's groundbreaking theory that describes gravity. Yet despite their theoretical existence, we have yet to observe a wormhole in reality. This gap between theory and observation is not due to a lack of trying. The universe is vast, and our ability to observe it, though improving, is still limited. Detecting a wormhole, if they do exist, is like finding a needle in a cosmic haystack. They could be microscopic, hidden in the quantum foam of space-time, or maybe they're out there, lurking between galaxies, beyond our current observational reach. And then there's the issue of stability. Theoretical wormholes tend to be highly unstable, collapsing almost instantly after formation. This instability is a crucial point because a collapsing wormhole is about as useful for space travel as a bridge that crumbles as soon as you step on it. Some theorists propose that exotic matter, or some form of quantum gravity effect, could stabilize wormholes, but these are, for now, speculative ideas. It's also worth noting that even if wormholes are real and stable, there are still considerable challenges to using them. Imagine trying to navigate a ship through a violent sea storm, but the storm is made of space-time itself, and the ship is susceptible to being crushed by tidal forces or incinerated by radiation. While we haven't found any wormholes yet, that doesn't mean we've given up on the idea. The quest for the discovery of wormholes is far from over. It's a journey that may take us to the very edge of our understanding, pushing the boundaries of what we perceive as possible. It's the ultimate exploration, not just of space, but of time and reality itself. Scientists aren't ones to back away from a challenge, and the quest to discover wormholes is no exception. The future of wormhole research looks incredibly exciting and is filled to the brim with possibilities. At the forefront of this research is the idea of harnessing exotic matter. Now, what's exotic matter, you ask? Well, in the simplest terms, it's a type of matter that contradicts the basic laws of physics as we know them. It's thought that this exotic matter could be the key to stabilizing wormholes. You see, wormholes, if they exist, are incredibly unstable. They open and close so quickly that not even light could pass through. But with exotic matter, which is believed to have negative energy density, we might be able to prop these wormholes open long enough to study them, or perhaps even travel through them. Now let's imagine a world where we've managed to stabilize a wormhole. What does this mean for us? Well, for one, it could revolutionize space travel. Instead of spending hundreds or even thousands of years to reach distant stars and galaxies, we could simply step through a wormhole and arrive in an instant. It's like having a shortcut through the universe. But the implications go beyond just space travel. The discovery of wormholes could change our understanding of the universe itself. It could be the missing piece that unites quantum mechanics, the study of the very small, with general relativity, the study of the very large. This would be a scientific breakthrough of unparalleled proportions. The road to discovering and understanding wormholes won't be easy, but the potential rewards are too great to ignore, so scientists continue to delve into the complexities of the universe, pushing the boundaries of what we know and what we can achieve. The discovery of wormholes could revolutionize our understanding of the universe and perhaps even make interstellar travel a reality. Wormholes, for now, remain one of the great mysteries of our universe. As we've journeyed together through the twists and turns of space-time, we've encountered a fascinating concept that challenges our understanding of the cosmos. Wormholes, these hypothetical bridges connecting disparate points in the universe, have captured our imagination and curiosity. We've dissected the concept of wormholes, these curious cosmic shortcuts that could, theoretically, allow us to traverse vast distances in the blink of an eye. We've delved into the world of Einstein's general relativity, a world where space and time bend and warp, potentially giving birth to these mysterious tunnels. However, as tantalizing as they are, wormholes remain firmly rooted in the realm of theoretical physics. Despite our best efforts, we've yet to detect their presence. The challenges are immense. Detecting a wormhole would require technology far beyond our current reach, and the energy necessary to keep a wormhole open is staggering, to say the least. But that doesn't mean we've given up. Indeed, the pursuit of knowledge about wormholes is relentless. Scientists around the globe are conducting research, armed with equations and simulations, all in an effort to unlock the secrets of these cosmic curiosities. Theoretical physicists are wrestling with the implications of wormholes, their potential uses, and the profound questions they raise about the nature of the universe. As we stand on the precipice of discovery, it's important to remember that science is a journey, not a destination. Wormholes, whether they exist or not, have already expanded our understanding of the universe and pushed the boundaries of what we thought was possible. So, are wormholes real? The answer is still out there, waiting to be discovered. And who knows? Maybe one day we'll step through that door and find ourselves on the other side of the universe.